Hi guys, so today I'm gonna talk about the vector diagram of RC network and RL network. So first let us consider RC network. So consider a pure resistor connected in series with a capacitor, and the combination is energized by a sinusoidal function. Let us take capital V as the RMS value of supply voltage and capital I is the RMS value of current. When current I flows through the resistive element and capacitive element, there will be a voltage drop across these two elements. VR, let's consider it as the resistive drop, and VC, let's take it as the capacitive drop. Okay. So now you have the circuit current and resistive drop, resistive voltage and supply voltage. Let us project all these entities with the help of a vector diagram. So for vector diagram, let's consider current as the reference vector, because in case of series circuit, current remains the same. So we'll take current as the reference vector. Alright. With respect to current, let us project VR, which is the resistive voltage. We know that in case of a pure resistive element, the current I and the resistance drop VR are in phase. So taking into that in consideration, you can draw VR in phase with current. Once you are done with the sketching of VR, you can sketch VC with respect to I. So capacity voltage VC leads, the capacity voltage VC is lagging behind current I by an angle of 90 degrees. So project VC by an angle of 90 degrees. And the closing side of the triangle basically gives the supply voltage V. So angle between I and V is taken as the power factor angle or the phase angle. Alright. So once you have this vector diagram, you can proceed to draw something known as the impedance triangle. So impedance triangle, it is pretty easy to construct. So to draw the impedance triangle, first let us consider the vector diagram of voltages, and let's apply the Pythagoras theorem. So while applying Pythagoras theorem, let us take this length as x and this length as y. Okay. And this length is basically z. Right? Okay. So when you apply Pythagoras theorem, you would get z square is equal to x square plus y square, where z is the resultant, or along z you have projected supply voltage V. So it is V square is equal to x. Length x is equal to VR. So VR square plus length y is equal to VC. So VC square. So V square is equal to VR is the resistance drop. You can take it as I into R the whole square. VC is the capacitive drop. So you can take it as I into XC the whole square. So you will get V square as I square into R square plus XC square, or you take out this square root, so you would get V is equal to I into under root R square plus XC square, where the term under root R square plus XC square can be taken as the impedance of RC network, where Z is equal to R square plus XC square, or rather you can take Z square. So you have obtained z square is equal to r square plus xe square. Now if you were to compare this impedance relation, say equation 2 with equation 1, it follows the Pythagoras theorem. So equation 2, it is comparable with equation 1 in the sense x squared plus y squared is equal to z squared. So you can represent equation 2 in the form of a right angle triangle. So that can be represented somewhere over here. So x entity is r and y entity is xe. So r, let me write it over here, and xe, let me write it over here. The resultant of these two will give you the impedance z, and angle between r and z is nothing but phi. So basically you can find phi from voltage vector diagram, and also you can find an expression for phi from impedance triangle. Okay. Hope you understood. Thank you.